Hey, all right. So we're finding limits of polynomial functions today. And we know how to find limits of polynomial functions because polynomials are continuous. So you could use direct substitution to find any typical limit. But here we are specifically looking for limits to infinity. So we can see on A, the limit as x approaches negative infinity of some polynomial. Well, that is a lot easier than it sounds because this is just one side of our end behavior. If we can think about what the end of our graph is doing as x approaches negative infinity, essentially is it pointing up or down, then we're good to go. So notice this polynomial right here is already in standard form. And when your polynomial is in standard form, we can use our leading term test. That's why we know the leading term test. And the leading term test says if our leading coefficient is positive, then the right side is going to point up. And if the degree is odd, the left side is going to do the opposite thing. So we have an idea on the inside, it might do something like this, but we don't even, again, we don't really care what's happening on the inside. We care about what's happening at the ends of the graph because this is asking for end behavior. And x approaches negative infinity is the left side. So as we look over here at the left side, we can see it is pointing down. So the limit as x approaches negative infinity for this polynomial is negative infinity. The outputs are going towards negative infinity, which is unbounded. We will never be able to get to negative infinity. Negative infinity is something we cannot reach. And so to say the limit of something, the limit is negative infinity, well, that's unbounded. So technically this limit does not exist. So this reads negative infinity, which is unbounded, therefore does not exist. Let's talk just a little bit more about that being unbounded. Well, when you talk about my limit of something, like I'm reaching my limit of sugar for the day, I'm about to be at a point that I cannot go past, because if I have any more sugar, I'm going to throw up, or I'm about to reach my limit when it comes to running laps around this track. If I do one more lap, I'm just going to pass out. You have a limit. It is something you stop at. But infinity, you're never going to get there. So to say the limit of this polynomial, to say what is the limit, well, that doesn't exactly make sense. So we're saying negative infinity, we're giving the direction. We know what's happening right here. We're showing context. It is going towards negative infinity because it's pointing down, but it is unbounded. And so technically, therefore, this limit does not exist. All right, we really flushed that out, so these should be really quick down here. Notice on B, this polynomial is not in standard form. That's how they're trying to trick you, so I'm going to rewrite this. This is the limit as x approaches infinity of negative x squared plus 3x plus 4. So I put that polynomial in standard form. It is a quadratic. We know a ton of things about quadratics. And notice the leading coefficient is negative, so the right side is going to point down. And the degree is even, so the left side is going to do the same thing. Once we've applied our leading term test, we know what the ends of the graph are doing. So as x approaches infinity, that's the right side of our graph. Well, as x approaches infinity, the right side is pointing down. So we are again approaching a negative infinity, which once again is unbounded. Therefore, this limit does not exist. But again, negative infinity is important. We're giving the direction. We're showing context. We know what's going on right here. It could It could have played out a few different ways, but it was negative infinity, which is unbounded. We know the limit doesn't exist. Finally, on C, well, this polynomial is in standard form. The right side of our graph is going to point up because our leading coefficient is positive. The degree is even, so the left side is going to do the exact same thing. Both sides are pointing up. The limit as x approaches negative infinity. The left side of our graph is pointing up. So this limit is approaching a positive infinity, which is unbounded. We can never get to positive infinity. Therefore, the limit technically doesn't exist, but that whole phrase right there, that is our answer. That whole phrase is our answer. We're approaching infinity, which is unbounded. Therefore, the limit technically doesn't exist. All right, hopefully that helps a lot, because that's why I made this. All right, have a good day. All right.